section number 32, multiplying and dividing fractions. The first problem, I like to illustrate a point. If you have 7 over 9 times 4 over 11. Oh, forget reducing, although it is nothing to reduce. The rule is you multiply the tops and you multiply the bottoms. Well, I just denoted that. I mean, you can go and do the multiplication of the tops and the multiplications on the bottom. But the bottom line equals this. That is, if you have 7 over 9 times 4 over 11, you can just extend the division line. You can just extend it. Put brackets around everything. Then it's cleared out. It's 7 times 4. Okay, you can just extend it. Now, if it already was things in brackets, this is even better. If you have x plus 2 in brackets over x plus 3 in brackets, and you are multiplying this by x plus 4 in brackets over x plus 5. Well, the rule is to multiply across. Well, when you multiply the numerators, you get that. Get x plus 2 times x plus 4. When you multiply the denominators, you get x plus 3 times x times 5. X plus 3 times x plus 5. That is, you don't have to separate it. It's boom, straight across. That's all I'm trying to say. Alright. So now, since the title of the section is multiplying and dividing fractions, let's remember how we divide ordinary fractions, that is real numbers. If you have 3 over 7 and you want to divide this by 2 over 5, whether it's written that way, horizontally, or vertically, like this. Horizontal means left, right. Vertical means up, down. The rule is you keep the first number or the top number just like it is. See, here I'm reading left to right. Let's do this first. First, you keep these 3 things. I just circled the 3 things. You keep the first one the way it is. And since it was 3 over 7, I'll keep it that way. That's the first thing. The second thing is multiplication, division sign. You change that to multiplication. And the second number, you flip over. You keep, you change, and you flip. You keep the first number, there it is. You change the symbol to multiplication, and you flip over the second number. If it's multiplication and you want to change it, same rule. You keep it, you change to division, and you flip it over. And there's no doubt in my mind that this is right, because it's exactly what we said it equaled. Now, let's do the next one, the one underneath. Same exact problem. So now we read top to bottom. Here's the first thing we see, then we see division sign, then we see the second number. We keep the first number, we change division to multiplication, and we flip over the bottom number. And we get 3 times 5 over 7 times 2. You want to work it out? Fine. Make sure you get 10 over 14. But what I just went over so far for this section, that's arithmetic. That's what you learned last semester in your arithmetic or pre-algebra class. Or maybe you learned it 10 years ago. But this is an algebra class. So, let's do algebra. If you have x minus 7 over 3x plus 4, and you are dividing this by 2x minus 3 times 7x plus 9. Okay. you should ask yourself if you could factor any of those factors. And unless I made a silly error, the answer is no. I wanted it to be that way. So it's this fraction divided by this fraction. So the rule is you keep the first fraction, you change division, and you can put it in brackets. You change division to multiplication, and you flip over the bottom one, or the second one. The 7x plus 9 goes in the top, and the 2x minus 3 goes in the bottom. But since it's multiplication, not division, since we are now multiplying, you can just extend it. You can just extend the division line. Okay, but there was nothing interesting in this problem. Let's do one where you have the factor and other things. So suppose you were asked to do this problem. X squared plus 5x plus 6 divided by x squared minus 9 divided by x squared plus 7x plus 10 over x squared plus 8x plus 15. Suppose you had that problem. Well, it's a division problem, and if either this one or that one or both are fractions, then you play the fraction rule. If none of them were fractions, that is, if the x squared minus 9, this wasn't there, if it wasn't there, and if this was not there, we'd be done. It'll be x squared plus 5x plus 6 divided by x squared plus 7x plus 10. And I'm not exactly right when I say, oh, we'd be done. We'd have to factor the top and the bottom. But we wouldn't use the rule. Keep the first fraction, change the division to multiplication. Now, if you have this, you can always say, so at least one of these is a fraction, so we have to play the fraction rule. Just think of that as 7 over 1. So it's 7 over 1 times 3 over 2. Or if you had 7 over 3 divided by 5, you really need to think of the 5 as 5 over 1. That way you can keep the first fraction, 7 over 3, change division to multiplication, and now you have a fraction to flip over. Okay, if you didn't write over here this 1, it wouldn't be any big deal. But if you didn't realize 5 as 5 over 1 or 10 over 2, if you didn't think of it as some fraction, well then how would you flip it over? Okay, so let's rewrite the problem on top as a multiplication problem, and then we'll continue. So the x squared plus 5x plus 6 over x squared minus 9 stays the same. The bottom, what we're dividing by, the second number, the bottom goes on top. X squared plus 8x plus 15, and the top, x squared plus 7x plus 10, it goes on the bottom. Notice I never even put a time symbol, because when you multiply anyway, they're just going to get next to one another. Now we factor each of the factors. How do you factor? Factors are things that are being multiplied. It's the stuff in this bracket times the stuff in this bracket divided by this stuff times this stuff. The things that are being multiplied, those are the factors. First factor, x squared plus 5x plus 6. I want two numbers to multiply out to 6 and add up to 5 to put next to the x's. Plus 2 and plus 3 multiply out to 6, add up to 5. Since it's understood to be 1x squared, I want two numbers to multiply out to 15 and add up to 8. The product should be the constant, 15, and the sum should be the number in front of x's. The two numbers that do that are plus 3 and plus 5. They add up to 8, they multiply out to 15. X squared minus 9. It's a difference of squares. X squared is x squared. 9 is 3 squared. So you write x and 3 two times, one with a minus, one with the plus. Two numbers that add up to 7 and multiply out to 10 are 2 and 5. Positive 2 and positive 5. Okay. So what does this equal? You can say this cancels out to 1. You can say that cancels out to 1. You can say this cancels out to 1, and you can say that's what's left over. X plus 3 over x minus 3. The only thing is, sometimes those things that you crossed off as 1 may not be 1. For example, x plus 5 over x plus 5 is not 1 if it were 0 over 0. And that happens when x is 5. So I won't allow that. X plus 2 over x plus 2, that's not always 0. It's not 0 when x is negative, it's not always 1. It's not 1 when it was 0 over 0, which happens when x is negative 2. The x cannot be negative 2. Alright, x plus 3 over x plus 3, most times it's 1. I agree with that. But not when x is negative 3. You can't allow x to be negative 3. So if somebody were to ask you, me or somebody else, what does this mess equal when x is 7? You can put 7 in there, or you can say x is 7. 7 plus 3 is 10. 7 minus 3 is 4. The answer is 5/2. 1, 2, 3. And by the way, 7 is not one of these numbers that x is not allowed to be. So again, the final answer is it's x plus 3 over x minus 3, but x cannot be the numbers 5, negative 2, and since I ran out of room, I'll say the negative 3 in the bottom. The equal sign is only valid if x is not 5, negative 2, or negative. If I ask you, is 5 better? This is not x. This is so the equal if x is 5. Because there's other notations. Instead of writing everything above and below the equal sign, at the end you can write comma, 3 over comma, 5 is 3. Now you have to relate the estimation answer 3 over x minus 3 is only correct if x is not 5 minus 2 or minus 3. Let's try another one. So it's a division problem. It has a typo, which I'll fix. So we need to convert it to a multiplication problem. We keep the first fraction the same. X squared minus y squared over x squared minus 2yx plus y squared. And you flip over the bottom. The x minus y goes on the top. The x plus y goes on the bottom. And then you try to factor each factor, x squared minus y squared. Well, that's a difference of squares. After all, x and y are being squared with a minus in the middle. So you write down x and y 2 times. One gets a minus, one gets a plus. X plus y can't be factored. Let's do this one next. X plus y, it can be factored. It is factored. It can't be factored anymore. The last one, bottom left, x squared minus 2yx plus y squared. Since this is understood to be 1x squared, first of all, let me write it a bit more clearer. Since it's 1x squared, it's going to be x followed by, not necessarily a number, x followed by something, times x followed by something. The two things should multiply out to the constant and add up to the number in front of x. Two things that multiply out to y squared and add up to negative 2y. Well, that's negative y and negative y. So that one's done. X minus y and x minus y. Negative y all squared. If you multiply these two, you do get y squared. And if you add them, you'll get negative 2y. You get just what you want. Negative 2y for the sum and positive y squared for the product. Alrighty, now we're in a position to start crossing out. Cancel it. Well, you have this canceling, and you have that canceling to 1. Well, you have x minus y over x minus y. That's not always 1. It's not always 1. This is not 1 in case x minus y is 0. Well, bring y to the other side, and you learned it that x cannot be y. Okay, whatever y is 7 or 9 or negative 53, x cannot equal that number. And for the other canceling out, we were incorrect in saying x plus y over x plus y is 1 under the condition that it's 0. 0 over 0. X plus y is 0, then you get 0 over 0, which is not 1. You bring this over, and you say x cannot be negative y. Well, x cannot equal positive y, and x cannot equal negative y. Shorthand way of writing that is x cannot equal plus or minus y. And, this also cancels out. But we already talked about that right here. We said about x minus y over x minus y already. So in fact, you get 1. This is just a complicated way of writing 1. This is just a complicated way of writing the number 1. The only thing is, x and y x cannot equal y, x cannot equal negative y. As long as that's true, then that must equals 1. Okay, so if somebody were to say, now of course the average person will not know this answer immediately, and I will not know it in an hour from now. But right now I know that what you see in that box is 1. Now suppose I tell you x is not plus or minus y. And I ask you, how much is this? That's then x squared. X squared. So write it down neatly. If somebody asked you what this equals, and for most people, this would take a while to answer. If somebody were to ask you what that equals, and all they tell you is that x and y are not equal and x does not equal negative y, you should just say 17. Because that's 17, and we coincidentally just spent a lot of time figuring out that's 1. We computed that to be 1, and 17 times 1, 17. Okay. So you should be able to do that, and I generally ask silly questions like that. That way people who don't think, to be honest, don't get A's in my class. If you're not thinking, you're not going to get an A. So that, upon finishing that last problem, that completes this section entitled Multiplication and Division of Fractions. Good luck with it.